Hello everyone, today I will be showing you how to program and tune PIDF loops. The end result will be something like this, an arm where I can set the angle and it will hold that position. So why should we use PIDF loops? Well, a PIDF is a form of feedback control loop. This means that it will be able to take in information about the error of a desired system and output that in the form of a power to correct for the given error. For example, when you implement a PIDF loop in the case of an arm that extends up to score, you can set the angle of that arm, and it will be able to hold that angle with no drop or sag due to gravity. By using PIDF loops, systems are able to be more consistent and accurate. This can be seen a lot in Freight Frenzy, when teams would score and they need their arm or mechanism to hold its place while they deposit an item. Now that we've talked a little bit about PIDF loops and their uses, let's get started with actually creating a PIDF controller. First, I will be installing FTC lib, a useful library for FTC-related programming. I'll be utilizing its built-in PID controller class. It's important to note that you should already have Android Studio set up with the FTC SDK. If you don't have it set up already, you can refer to our video tutorial that we have linked in the description box below. To install FTC lib, head over to your build.common.gradle file and add Maven Central to the end of your repositories block. Next, you'll want to set the min SDK version to 24 within your default config block. Finally, in your build.gradle file for your team code module, you'll want to add the implementation for FTC lib. The second library I'll be using for this program is called FTC Dashboard. This will allow us to modify our PIDF constants in real time, as well as graph the current position and target position, and will save us a lot of time during the tuning process. To install this library, we will add this desired piece of code in the build.dependencies file. Next, we will add the implementation for FTC Dashboard. Perform a Gradle sync and you are done. Now that we have the libraries we need, we can start programming. The first thing you need to know about PIDF loops is that they have two parts, the PID controller and the feedforward. In this case, I will be using a feedforward component that counteracts gravity, as well as a finished PID controller to drive the arm. For the first part, you will need to create a PID controller member object, along with the three coefficients of a PID loop, being the proportional, integral, and derivative gains. Next, you'll want to add the feedforward component as well. To make sure that we can adjust our motor's position in real time, we will also add a target motor position in ticks for the motor to go to. We will also make a constant for the total number of ticks in a degree. This will vary depending on the motor you're using. In this case, ours is 700 divided by 180 degrees. Last but not least, we will want to create our arm motor. We will also want to add the @config tag at the top of our teleop so that the FTC dashboard is able to recognize that this script wants to be modified in real time. That is the same reason why these variables right here are also declared as public static. Next, I will initialize all of the components. Now that everything has been initialized, we can begin to create our actual PID loop. The first thing I will do in my loop is set the P, I, and D components of the PID controller object. I will then get the position of my arm using the .getCurrentPosition method of my motor. Now that we have all the components for the PID part of the controller, I can then calculate the power using the .calculate method. Finally, I will calculate the feedforward component. I'll do some simple math and multiply it by our feedforward constant, made right here, and then I will add the power and the feedforward together to get the power that we will pass into our arm. To better understand the math behind this, I have linked a useful article in the description box below that dives more in depth into these concepts. I will also add some useful telemetry for use when tuning an FTC dashboard later. Now that we've programmed our PIDF controller, we'll then need to begin the tuning process of it. We'll start by introducing our feedforward component. We'll set this to something like 0.05 to see if it can properly hold the arm from falling due to gravity. If it can't, then we'll need to increase this term slightly each time. Once we've tuned the feedforward component, we can then introduce our proportional term. We will increase this based on whether or not it's reaching the target position. As we can see here, it was not reaching the position accurately, so we needed to increase and decrease this around just a little bit to see if it would work. We ended up setting it a little too high though, because we set it to 0.005 and that added a little bit of overshoot to it, as seen here. To combat this, we decreased our component slightly. Finally, once we have our proportional term done, we introduced our dampening component into the controller. This acts as a dampener on the oscillations of the PIDF controller. If all of that works, then you're done. You can modify the values as you choose to see how the program interacts with itself. Feel free to ask any of your questions about PIDF loops in the comments below and let us know if this tutorial helped you. Thank you so much for watching, and don't forget to like and subscribe.